Hey guys, so this is going to be video 3, and today we're going to be talking about normal, pretty easy Auton controls of just going forward and something about iterative design processes. So let's just get started off with how to make simple autonomous functions. So let's go to include and let's create a new header file. We're going to call this Auton functions.h. And we're going to make it new CPP file. Call that also So now that we have created both of our files, we're going to go to auton.h. We're going to use these header cards, so I'm just going to copy this and paste it right here. But we're obviously going to have to change it, so we're going to change it to auton functions. And if file. So now that this error will go away. And we can write our code in the middle. So now we need to declare some functions that we need to declare functions that we have to use. So the most simple basic function that everybody starts out with is move forward functions. We're going to have a void move forward crawl. And I'll go into why I call it crawl. Later on. So, and then we're gonna have to declare some parameters, because when you move forward, you just don't call a method. You have to specify some numbers. For example, you have to tell it what the speed that it's going at, how much does it need to travel. But for this one, we only really need to talk about speed, and we don't need double, float, or any of those data types. We only really need an integer, so we're gonna do int. We're gonna call it speed. And then we're going to go to autonfunctions.cpp, and then we're going to do include VEX.h and include autonfunctions.h, and then we're going to use using namespace VEX, and yeah. So then we're going to go back to our autonfunctions.h. We're going to copy this. So make sure we don't do any errors as we do that. Curly brackets. And now we're going to talk about, okay, how is this going to work? So what we're going to do is we're going to have our left motor. So motor back left dot spin, and then we're going to use forward, and then we're going to use this as a parameter because we don't know we don't want to predetermine the speed, we want to be able to choose. So for instance, sometimes you might need to go full speed, or sometimes you really need to go slow because you need accuracy. So we're going to choose, we're going to write speed here, and we're going to be using percentages, so PCT. Then we're going to do is copy this, and then we're going to paste it. Now we're going to do this back right, this front right, and front left. Usually I keep it alternating, so this should be actually front left, and this should be front right. So now what this does is basically when you call this function, what it's going to do is it's just going to spin the motors infinitely, and it has no stop, and just spins them infinitely with a certain speed that you give it. So now we're going to go to our main CPP, and let's include our auton functions. So include auton functions.h. Now we're going to go to the section called void autonomous. So we're going to put our code here. We're going to call, first let's build so we can get rid of all these errors. And then we're going to build. And then now we get building success. So now we're going to put move forward. And then we're going to declare it as going 50 speed. Now that's done, you download that to the robot and you see that the robot now listens to your commands and it goes forward at 50% of its max speed. But that's not what you want. You don't want a robot to continuously be spinning. You want to give it a set distance. And you want to say, okay, after the set distance, I want you to stop. So how do we do that? Well, we're going to go back to autofunctions.h and we're going to create a new void function. We're going to call this move forward walk. And then we're going to have two parameters instead of one. We're going to still have this speed. We're going to have int speed. But we're also going to have a double because sometimes you want to go a fourth of an inch, you want to go half an inch. So you need this precise movement. So you need something that can be able to do this. So we're going to do double distance in inches. Gonna be done. I want to go to autofunctions.cpp and for that I need to copy and paste this. So copy this and paste this right here. So the reason that I have two different move forward functions is for something called the iterative design process. The reason I do an iterative design process is, and the way I do it is I have a program called crawl, I have something called walk, and then I have something called run. The reason for this is basically, let's say when you get into more complex coding, so let's say you start messing around with motion profiling, PID, odometry, and you notice, okay, let's say maybe your base starts curving, and you see, okay, while I'm driving straight, it starts curving. Why? Is it the actual base that's curving? Or is it my code that causes it to curve? So the way I check it is I say, okay, let's comment out that function, and let's say now let's use our crawl program, because we know the crawl program is so easy that there's not going to be a lot of errors in that. So there's not going to be any human errors from code because of how complex it is. So then when we run it, we see, oh, the robot actually does go straight. So then you know that it's actually not the robot's fault, it's actually your code's fault. Or maybe it actually does curve in the crawl program. So if it does curve in the crawl program, then you know, okay, maybe it's not actually my code fault, but it's the way that the builders built it, or there might be some friction, or maybe a motor might be dead. So that's something else you might have to figure out later, but this solves you an issue of scratching your head and thinking, oh my god, how do I figure this out? And another reason is sometimes you really want these simple functions. For some instances, sometimes you don't want to use your motion profiling program, PID program. You just want a simple move forward at this constant velocity and then stop. Or continue spinning in a while loop until it determines something. That's why you always want simple functions and complicated programs. So now let's move on to creating this next level above, so our walk program. So the way the walk program is going to work is we're going to be taking the diameter of the wheel, we're going to find the circumference, and we're going to figure out how many ticks per revolution do we need to reach our distance. So to do that, we're going to have a double, and we're going to call this wheel diameter. And we're going to call that, let's say you're using a 3.25 inch wheel, so we're going to do 3.25 in this case. And then we're going to have another double, and we're going to call that circumference. And we're going to say that is equal to 3.14 times your wheel diameter. Then we're going to have another double variable, and that's going to be called degrees to rotate. So what this basically does is now I'm going to be taking so we're going to do what we're going to do first. We're going to do 360 times distance in inches to convert this into degrees, and then we're going to divide this by our circumference of the wheel. So once you do that, now you have an accurate way of telling, okay, now I can convert basically inches into ticks per revolution of a wheel. So now we're going to be using something integrated in the motors themselves called IMEs. What they are integrated motor encoders. So basically, they're like normal encoders, but now they're integrated in the motors. We'll get on later on to what trackers are, but for now, let's stick with integrated motor encoders. And with my personal use of them, they're perfectly good way of estimating distance, and they're accurate as well. So we're going to do front left dot, and now we're going to use a different API. We're going to use something called rotate 4. So what this rotate 4 is going to be doing is, okay, let me use the one with, okay, so this rotate 4 is basically you're giving this parameter and you're going to say, okay, I want you to rotate this many times, and once you rotate this many times, I want you to stop. So we're going to do rotate 4, and we're going to want to go in the forward direction. We're going to say the amount of rotations that it needs to complete is going to be degrees to rotate, and then we're going to be using degrees, or actually it's actually deg. We're gonna say what's the velocity. So velocity is the other parameter, and that's going to be speed, and then we're going to be using that as in, and then we're going to be using as in percentages. So we're going to say PCT, and usually it sometimes doesn't like that. So we're going to do VEX. No, sorry, not VEX. Velocity units. Semicolons PCT, and then boom. Now we're going to copy and paste 4 times again, and we're going to change this to front right. We're going to change this to back right. Back left. I made the mistake again. Change this to left, and we're going to change this to right because you always want it alternating. The reason is I've noticed sometimes if they're not alternating, sometimes one side of it stops faster than the other, so you sometimes turn. But I don't know if that's a problem with my robots usually, but just for that case, when I do it this way, it fixes that issue and goes away. So now we're going to build, and we're going to see that there are no errors. And now that once it's built, we're going to go back to our main.cpp files, and we're going to go into autonomous, and we're going to say, okay, now we're going to also do move forward walk. And let's say you want to go same 50 speed, and let's say now you want to go, excuse me, length of the tile, which is 24 inches or 2 feet. And boom. And now you say that I'm downloading this to a robot, and you run, and then you'll see, oh, it does go 24 inches. Cool. And now you can play around with that, and you can play around with the move forward crawl and figure out where does it have a purpose of having a continuous spin function, usually in while loops. So I'm going to leave that to you guys to figure out. Remember, if you guys have any questions, leave your comments. And yeah, I hope this video helps you guys. Thanks. See ya.